Step Talks Education. Let us continue with chemistry, and we are on atomic structure and chemical bonding, and we had already looked at what we call chemical bonding, and we had a look at the formation of ionic bonds, which we said forms between atoms of metals and non-metals, and is as a result of the complete transfer of electrons from the outermost shells of metal atoms to the outermost shells of non-metal atoms, which leads to the metal atoms becoming positively charged while the non-metal atoms becoming negatively charged. So we looked at how these bonds are formed between atoms of different metals. We had a look at the diagrammatical expression of, or the illustration of how the bonding takes place. Now, we see that the ionic type of bonding leads to the formation of what we call ionic compounds. So today we are going to look at the properties of ionic compounds. Please remember that the ionic compounds consist of what we call ionic bonds. So when we talk of their properties, we refer to their characteristics. You need to know them and see how best we can use the knowledge of the properties of ionic compounds to identify them when you have been given some, say, tabulated data on some characteristics or properties of some of some substances. So the properties of ionic compounds: one, they are made up of ions. That means they are ionic and not molecular. So they are made up of ions and not molecules. Remember, we said that these ionic compounds, firstly, there is the formation of the ions, oppositely charged ions, whereby the metal atom forms a positive ion by losing electrons completely from its outermost shell, and the non-metal atom becomes negatively charged. It forms a negative ion by gaining the electrons to fill the outermost shells. So in an ionic compound, we have got ions. That's why we say that they are ionic and not molecular. They're not made up of molecules, but ions. Two, they are solids at room temperature. So a substance which is a solid at room temperature, supposing the melting point is, say, supposing the melting point of that substance is X degrees C, and then the boiling point, let us talk of just the melting point, because melting is a process which leads to the formation of a liquid. So if the melting point of a substance is X degrees C, it means that X degrees C is quite less than the room temperature. And here in the tropics, the standard room temperature is 25 degrees C, which is the same as 298 kelvins. So these ionic compounds are solids at room temperature, and in this case you find that they do not melt at room temperature, but they melt at a temperature which is above the room temperature. So at room temperature they are still solids. In fact, they are solids at room temperature. Three, they have high melting and boiling points. They have high melting and boiling points on top of being solids at room temperature, meaning that their melting points are above the room temperature. Again, they have very high melting and boiling points. A point in case is sodium chloride or common salt. It melts at about 800 degrees C, about 800 degrees C, which is far higher than the room temperature. So you find that at room temperature, they are still solids, all these ionic compounds. So they melt at a temperature which is above the room temperature. And indeed, the melting points are very high. Not only that, they are soluble in water and insoluble in other organic solvents. We have just seen that the ionic compounds are made up of ions, meaning that they are ionic, and for that reason they can only dissolve in an ionic solvent, which is water, but they cannot dissolve in other organic solvents like, say, cooking oil or petrol or kerosene or carbon disulfide or tetrachloromethane or methylbenzene. All those ones are organic solvents, and in this case ionic compounds do not dissolve in them because they are in this case what we call molecular solvents and not ionic solvents. And in this case, water is an ionic solvent, and therefore ionic compounds dissolve in water only. Next, they have high densities. Having high densities means that the particles are closely packed together. So you find that they are therefore what? Solids. That's why they are solids at room temperature. It is because even they have very high densities, they are hard. The particles are densely and closely packed. Then they conduct electricity in the molten state or in aqueous solutions, and therefore they are said to be electrolytes. They conduct electricity in the molten state. That means when you heat it and it melts, then the melt can conduct electricity. Or when you dissolve it in water, then it forms a solution. It is soluble in water. Now, when you dissolve in water, it forms what we call an aqueous solution. And then the aqueous solution, as well as the melt in this case, conducts electricity. Reason being, in the molten state or in the aqueous solution, in this case, these ionic compounds will be having free ions. Their ions will be set free. But they cannot conduct electricity in the solid state, since in the solid state they do not contain free ions. And for that reason, we refer to them as being electrolytes. And electrolytes are compounds, not elements, but compounds which conduct electricity either in the molten state or in the aqueous state. And for that reason, we have said that the ionic compounds are said to be electrolytes. They conduct electricity in the molten state or in the aqueous state, but not in the solid state. The reason is that, as we have seen, that in these states here, we have got free ions. The ions which are in the ionic compound will have to be set free by either heating to the melting point, and when it melts, or when you dissolve in water, you form an aqueous solution. And in the molten state or in the aqueous solution, you will be having free ions, which then conducts electricity. So they are referred to as being electrolytes. And mark you that electrolytes are not elements but compounds, and in particular they are the ionic compounds. So we have seen the properties or the characteristics of the ionic compounds. They are made up of ions and not molecules, meaning that they are ionic and not molecular. They are solids at room temperature, and in most cases you find them existing as crystals. So they are solids at room temperature. They have high melting and boiling points. So their melting points are much above the room temperature. In this case, that's why at room temperature they are still solids. So they have high melting and boiling points. And I showed you a case of sodium chloride, common salt, which melts at about 800 degrees C. That's a very high melting point. They can dissolve in water. They are soluble in water, but they cannot dissolve in other organic solvents. And I mentioned some, like cooking oil that we use. We talked of kerosene, we talked of tetrachloromethane, we talked of carbon disulfide, we talked of toluene, or what we call methylbenzene, and many others. So those are what we call organic solvents. They do not consist of ions. They are molecular and not ionic. But what is an ionic solvent? So ionic compounds dissolve readily in water, but not in other organic solvents. They have high densities. This is because they are densely packed, so they are hard. And then we say that they can conduct electricity when in the molten state or when dissolved in water to form an aqueous solution. And in these states, we say that they possess free ions, which helps in the conduction of electric current. So they are called, or they are referred to as being electrolytes. So these are the characteristics or the properties of ionic compounds. And this is Step Talks Education. Thank you for watching.